Today we are going to look at how to compute the measure of central tendency in our programming language SPSS. But before we continue, I want you to know that this screen is brought to you by Excel Consult Services in conjunction with Extraping Analytics Consulting Limited. My name is Vincent. If you want to contact us for professional IT training on data analysis, data science, the project management, advanced Excel, financial analysis, and other IT training. If you want to contact us, you can contact us at 150 Anchor Plus contact Lagos. That's what we say. Also, we offer both online and physical training. So, in continuation with our training on data analysis in R programming and SPSS, today we are going to look at the measure of central tendency and the measure of dispersion. How can you do this in R programming? How can you do this particular analysis in R programming? How can you run the code in R programming and SPSS? So when we are done with the training on how you can um, perform an analysis, a measure of central tendency using the R programming, the R Studio, and the XPSS, then we'll look at this particular case scenario. So let's keep the ball rolling. Now, first and foremost, we have to install some packages. Now, I've already installed the package in my last program. So the packages we need to install, in order for we to be able to control the measure of central tendency, we need packages like install packages. Install packages like the 1071 packages like the 1071 packages. Very much we install this particular package, it helps us to run the measure of central tendency, and also another package that can help us to run the measure of central tendency is the moments package. Now all these two packages has already been stored in my R Studio. Now you can see that, but currently it's not active. So if I want that package to be active now, well, when you run this, you install that into your app. Well, when you do that, you install that into your app. And then next you need to make it to be active. Not want me to make it to be active, I have to click on this to make it to be active, or I have to check this to make it to be active. That's to activate that before I can make use of it. Or alternatively, I have to use the library and N1071. But when I run the code, you can see the package is not active. So alternatively, the other package I can use in running the measure of central tendency is making use of the moments package. Making use of the moments package. But when I run this moment package, it will install it. Will install this particular package in your App Studio. Currently, I have this package in my system. Already, I have this package in my App Studio, so I don't need to run this final the moment package. Now you can see the moment package can help you to compose the skill, then the corpus and related. Also, okay, I think these are the two most important packages. The other package I'm going to use, also use in this particular analysis, is a package we've already stored in our first part of our training. That is a dplyr function. The dplyr function. Now I'm running this code. Installing this package will help you perform every analysis. Every analysis we are going to perform here today, you can make use of these three. We can make use of these three packages to perform this analysis. Okay. Having said that, now the first step was my working directory. I already set my working directory, and this is you want to set your working directory. You don't have to be showing all this time around. You have to set your working directory and get it into now to get working directory. That's working directory. To set your working, you set your working directory. and you load your data into R by using the read um, XL. My file name is Telescope, and you use the file name there. Okay, all those are already made. I did all this in the first part of the training. Now you can see, excuse me. Now, now my data set is already in my data set is already in my R Studio. We can view the data set. I showed us different way we can view our data set in last training. We looked at the various way we can view our data sets. We can use the add. We can use we can use the add function to view our data set. My data set is School. Okay, we run this and we can see the data sets and we can see some of our data set as the NA but is not restricted. Okay, now also we click on this, we can also view our data set. And this is my data set. I clicked on that, I can also view the data set and you can see some of my values are NA. Now, this particular data set talks about the telecommunication service. It is a telecommunication company, and the telecommunication company are into this, they render some telecommunication services to people, such as the toll-free call, that is the toll-free call, the long-distance call, the cardless call, the wireless call, and the rental equipment services. Now, these are the five major services that are being offered by this telecommunication company, and these are the data set. And this is a data set of the particular company that's been pulled out from their database. Okay, now, so in a different way, you can view our data set. You can also use the view function in R to view our data set, which is Tesco, and we run that and it gives us the dataset. Now we can see the dataset. We can also use another function in R to view our dataset. We can use the glimpse function in R to view our dataset. Excuse me. Now you can see that gives you a glimpse of your dataset. Now let's look at the measures of central tendency. Okay, let's look at the measure of central tendency. First and foremost, computing the mean. Now, how do we compute the mean in R? Okay, compute the mean in R, we can use the main function to compute the mean. And our data set is still school. That's the file name of our data set, as you can see here. The data set is still school. So that's the data set, that's a file. Then the column in which I'm interested in. As you can see, my data set, I have a list of columns, and I'm interested in this particular column. These are the services rendered by this particular company. The long distance call that we call the normal, the toll free call, the equipment call, the equipment, the toll free call, the rental equipment, and the cardless services. So, and these are the five major steps. So, if I want to look for the mean of the, let's assume I want to look for the mean of the long month call. That's for the long distance call. In my data set is known as long month. So, I run this particular data set. That gives me the mean for that particular data set. So, for that particular variable. Then, if I want to compute the mean for the other variable, that is the long model toll free call, known as the toll. I can simply compute that and I run that. So that is telling me that is and because of the NA value I have, it's telling me it's NA. Now when you go to this particular data set, we can see that the 2 month has the NA value. So we need to take care of that. How do we take care of that particular problem? How do we take care of this particular problem now? So let's look at the order. Let me try to running Let me try running the main for the other variables. Um, the test code. Now we have the test code. The other variable is the toll-free call, and after the toll-free call, we have the rental equipment and the card mode. That is the rental equipment, and then the other is the cardless services, the card mode, okay, and the other one we need to is the wire mode. All the rest were giving us na value. Okay, now having this na value, we can also do that on the other way we can okay, we can take care of this na value. Um, so let's say how can we take care of this na value? Now let's use the test code equals to test code equals to let's introduce a pipe function and let's make use of the multage function. Now using this multage function, now this multiplier function, using the multage function, I want to take this, okay, I want our studio to replicate this as a multage, that is to duplicate that. Multage equals to, no, we're having 0 in 2 months, okay, equals to, okay, multage equals to if s, that if the 2 month service is none, okay, if the 2 month service is a now I'm telling how to duplicate this particular um how I should duplicate this particular table. That's that particular file. That's my table name for my file name. How I should duplicate it, and this particular column that is 2 month, where the value of that is none is NA. How should replace it with 0. Otherwise, I should just return the 2 month, the value for the 2 month. Okay, I can run this particular, and when I run this particular code and I rerun this particular code, now you can see it has given me a value now. So I could simply duplicate all this. I could simply duplicate all that. The next is the equipment. And the next is a card one. And the next is the wire mode. Okay, I could simply run all this line of code. Now, the moment I go to my dataset, um, let's try viewing the dataset. Okay, now go to our dataset, you can see the NA value there, but have done that, they now recomputing the mean of our data sets when we decide to compute this mean. Okay, yeah, we're having some problem with this. Okay, we have to change all that to the other variable, and this is card one. So let's try changing this to then change. Let's try changing it to the other variable, the variable that we are interested in. Then let's look at them. Let's change this. We need to align this. Let's run all 1, 2, 3, 4, and okay. These are the four variables, and we run this. Okay, let's see this two more. Initially, we run the two more. Okay, let's see what we are seeing something here. Okay, let's say tells q equals to tells q rotates two more if else is not, yeah, is two more is zero is NA, return change it to zero, otherwise return the two more, the quick more. Okay, these are the main value that are given to us. Okay, now these are the main value that we got. Let's check the data set. Let's see our data set. Now let's look at our data set. Now you can see the data set for the where is it? Now you can see our data set for the long month, the 2 month, where the values were NA, it has changed to zero. Okay, when the values were NA, our studio converted that value into a zero. Okay, now, so now we are able to compute the mean for that for each of our variables. Now, for the long distance call, the toll free call, the equipment, the rental equipment, the cardless services, and for the wireless services, we are able to compute the mean for each of those services. Okay, now let's try computing the mode. Now let's try computing the mode and let's see. Okay, we can see computing the mode. We have the first, all are giving us numeric, 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 numeric. Why are we having this numeric? First, it's telling us. Okay, sorry. In computing the mode, we don't need to use the mode function. Then the mode function will give us the class of our data sets. Now, sorry for that. And that gives us the class of our data sets. It tells us whether our data set is a numerical variable or is not it gives us the type of data set we are dealing with. It's telling us all our data sets in web programming. So if we want to compute the mode of data set, we rather use Let's rather use the computing the mode of our dataset is better. We use the table function. Now we use the table function, and that helps in computing the mode of our dataset. Now you can see our dataset. You can see that in our dataset. Now when you can see that when we have like 17.45, it's telling us that appears once in our dataset. Okay, that 17.45 appears once. And if we compute the mode, and let's go to our dataset for the two mode. Okay, and this is for the two. It's still loading the dataset. Let's look at um, use the table for let's use it for this. Okay, let me quickly delete all this. Okay, let's use the table value for that. Okay, now for instance, when we have this particular value, when we have this particular value, for instance, we look at let's say 7.555, 7.55. That is what that is a long month phrase. 7 point. Okay, when you look at the data set, we have 7.55, 7.55 in our data set. Okay, 7.55. Okay, let's assume 7.75 or 14.70. Okay, 7.75 or 14.70. Okay, 14.79 instead of 14.7 appears only once. 14.5, that is 14.5 appears four times. 12.85, that's 12.85 appears five times. Now, that is the mode of our dataset. So we can um, check for the mode of our dataset using the table function. The table function can help us in checking for the mode of our dataset. Also, there's other way we can look for the mean of our dataset. We could also use this particular function. We're interested in normal. We introduce the pipe function. Since we are interested in the mean, we'll make use of the mean and we'll run this. And that gives us the same value we got um, while we run this. Now you can see we have similar um, outputs. We have similar outputs, similar results. So we can also compute the mean of our dataset by using this. Now this time around, let's look out for the two more. We introduce the pipe function and for the main. I will run this, and that gives us the main value. We'll run this, and we'll say we've got similar value. Also, we can use the dplyr function. Also, we can use the dplyr function to look for the mean of our dataset. We can also run the main, look for the mean of our dataset using the dplyr function in looking for the mean of our dataset. Using the pipe function, make use of the summarize function where we have the, since we are looking for the mean, let's call that the mean of the long run. The mean of the long run is equal to, the mean of the long run is equal to the mean. Now, this is a file name. The name of our file is Tesco. Then we introduce a pipe function, and then we use the summarize function to run the mean. Now we can see the mean for the long run is giving us 11.0. But when we use this particular function, it's giving us 10.9. Now you can see using the declare function helps us to approximate the value for the mean. So I could also use that to look for the mean of the toll mode. That is the long, that is the toll free service. That the toll free service. The mean for that particular service. That the toll free service. Okay. Now the toll free service. We could also add the other variable and we look for the mean of each of the other variable. Now this is the rental equipment is equal to the mean for the rental equipment. I will look for the mean of the cardless service. So we look for the mean of each of our variables using the declare function. That is this is a card one, and the last one now is the mean of the wireless service. So this is wireless what, let me look at the wire one. Okay, now we've looked at the mean for each of those variables. It's giving us an error here. What are we missing? Let's quickly run all this. Now, when we run all this, we can see the value for each. We can see the main value for each of those variables. We can also use this. Now, take note, we've taken care of that. Now, we can also look for the median value of our data set, the main mode and the median. We can look for the median value of our data set by using the median function in our studio. And the first variable of our first variable for the long distance call, we can see the median value for the long distance call 7.5, and we could also compute the median value for the other variable, which is the 2-month service. Now that is a median value for the 2-month service, and we can also compute that for each of our variables. Okay, let's simply copy this. Okay, let's simply copy that and paste it. Now all I need to do is to get the median value, then Okay, now we can run all this all over again. And that gives us the median value for each of these variables. Also, we can also decide to use the declaration function to compute the median value of our variables. Okay, instead of using that here, we now have the mean. So replacing each of those value, and this is just the name given to, and this is just the name given to output. So we can give that any name. Now you can see the median value is the output or the result is similar to what we got here using the alpha using the A1071 function. So using the declare function and that of the E1071 function, you can see we got the same value for the median value. And this is how to calculate the measure of central tendency using the house. And let's see how we can do that using the how we can calculate compute the mean, the minimum, and the standard deviation. That is a measure of dispersion in our studio. Now that gives us the minimum value of that. So we could also use this, we can also compute that by using there's a finding, the column I'm interested in is a long distance call. I will introduce a pipe function that introduces the pipe function and the minimum value. Okay, this also helps in computing the minimum value. This also helps in computing the minimum. But also, we can also compute there are many diverse ways we can compute the minimum value. But let's just pick this. Now, we need the mean value. Okay, let's change this to mean. Let's change that to the median value. Let's change that to the median values. Let's change that to mean. Sorry. Let's change it to mean. I want that to be the mean. So this is just the name. Okay. This could be any name. So run this. That gives us the minimum value. Now you can see the value is the same while we run using this particular code. So we got the similar value using the same code now. So that's the declaration function. Also the maximum value, the maximum function we could also run the maximum. We can also find the maximum value of our data set, the maximum value for the long distance call. In other words, the maximum amount of money that is spent by the customer on long distance call. Now, this is the minimum amount of money that is spent by the customer on long distance call. So the maximum amount that is spent by the customer on long distance call, that is, this is the value. The maximum amount, we can also look for the maximum amount excuse me, can also look for the maximum amount that is spent by the customer on long distance call. Also, likewise, we can also use the declare function to look for the maximum value. Just the same way we look for the minimum amount that was spent on the long distance call. We can also use the declare function to look for the maximum amount that the maximum amount that was spent on each of the services. Okay, the maximum amount that was spent on each of the services last month. We can also use this to check the maximum amount that was spent. We can also use it to check the maximum amount that was spent on each of the services by the customer. Now we run this, that gives us the maximum amount of money. Now we can see we got to the minimum, we got the maximum, we got the minimum, we got the maximum. You can also compute this for the standard deviation. Now computed for the standard deviation makes use of xt and this actually. Now we can see we've got the same similar value. Also, we can also use the declare function to compute the standard deviation for each of the services, the amount for each for the month for the amount of money that was spent by the customer on each of the services, on each of the service rendered by this particular company. So we can also use the declare function to find how the deviation from the mean value of the mean amount that was spent on each service by the customer. Now that gives us the standard deviation, how the values that were spent, or how the values that were spent by the customers on each service deviate from their mean value, from the mean amount. Now we can also compute the range. Now we can use the range function to now we can use the range function to compute for the range. Now computed, we can see the range gives us two values. Okay, using the range we have two values, so we can use the minimum function. We can use the minimum function. We can use the minimum function and check the minimum amount of money that was spent by the customer on long distance call for the previous month. Okay, so let's now that is the minimum amount of money that was spent by the customer on long distance call in the previous month. We can also check for the maximum amount of money that was spent by the customer or long distance call for the previous month by using the maximum function. Then we can now look for the range. We can look for the range. We can look for the range by saying we could say this should be x. Okay, rather let's call that range. Okay, let's call that range equals to. Now we've seen that um, the range is equals to the maximum amount of money that was spent on the long distance call minus the minimum amount of money that was spent on the long distance call. Now that will give us the range. Now when you subtract this value 0.90 from 99.95, that gives you the range. Okay, that gives you the range. So now what is the range? Let's run this. Now you can see this. Now you can see that is the range. Now that gives you the range. Okay, we can also look for the variance. We can also calculate the variance. We'll change this to the using the var function. Using the var function, that gives us the variance for the long distance call. How it varies from the main value, and we can also compute that. We can also compute that. Can also compute that. Can also compute that using the var function. Now, now let's look at interquarter range. In computing the interquarter range, we use the quantile function. We use the quantile function to get the interquarter range. Um, we use the we use the quantile function to get the interquarter range. For instance, we have this. Let's look for the interquarter range. Let's look for the quantile for the long distance call. That gives us the first quantile, the second quantile, third, fourth, and the fifth quantile of our data set. Now we can see that the 25 quantile of our data set is 4.5 and the 75 quantile of our data set is 14. Now we've gotten this quantile, we can also decide to compute what is quantile 1 of our data set. Let's assume we can make this to be quantile 1 of our data set. Okay. Okay. Let's name this. Let's call this quantile. Okay. Okay. Let's call it quantize. Okay. Let's call that quantile is equals to this. Okay. Then let's say quantize. Okay. That is the first quantile. That gives us the value. You can see 0.9. We have 0.9. We can also look for the second quantile and the fourth quantile of our data set. So let's look at the fourth quantile and the second quantile of our data set. Now, looking for the fourth quantile and the second quantile of the long distance call, we can see that the second quantile, that's the 25th percent of our data set is 4.5, and the, the 75% is 14.0. Now we can look for the interquarter range. Now that is the interquarter range. we can get the interquarter range. Now we can compute the interquartile range of our data set. Now we can compute the interquartile range of our data set. Now we can compute interquartile range of our data set by, okay, we've already gotten quantile. We've already gotten quantile, so we can say uh, okay, interquartile range is equals to this. Okay, that gives us the interquartile range. When we subtract 4.5 from 4.0375, it gives us 9.5. Okay, that is the interquartile range of our data set. Okay, we can also compute the distribution of our data set and the distribution of the various services performed by the various services that are being carried out by this particular company. We can look at the various amounts of customer spending, the spending pattern of customer for the various services offered by this particular company. We can look at the skewness and we can look at the kurtosis. Okay, in computing the skewness and the kurtosis, we use that to compute the skewness. We can see the argument for the skewness. Okay, we are interested in the first argument here is for the, for the long distance call. This is the skewness. As for the long distance call, that's for the skewness. Okay, that's for the skewness. You can also likewise compute for the kurtosis using the kurtosis function. Okay, using the kurtosis function. Now you can see the kurtosis function is the moment function for the long distance call. Now you can see the skewedness for the amount of money that was spent on long distance call for the previous month is skewed to the right because we have a positive 2.96734. So is skewed to the right. So most of the data set are skewed to the right. Most of the amount of money that we spend on long distance call by the customers are actually skewed to the right. Now we can also look at that the kurtosis of this particular the amount of money that was spent on this on the long distance call for the previous month by the customers, we can see that the kurtosis is 13.87442. That means the height of the distribution is very very high. Is victopotic in nature. Also, we can also use the Doppler function. We also use the Doppler function to compute for the mean. I'll also use the Doppler function to compute for the skewness and the kurtosis of our data sets. We can use the Doppler function to compute the mean and the kurtosis of our data set. So we could simply quickly change this to skewness. Okay, and we can do that likewise here. Okay, we can also quickly copy and paste this. Then we compute the kurtosis of our data set. So we can paste that, and that gives us the we can see the skewness of our data set that for the long distance call, the skewness is 2.97, approximately 2.97, and that says it's positive, that means it's skewed to the right. For the toll free call, is 1.95. That means it's skewed to the right as well. It's positive. For the rental equipment, it's also skewed to the right and it's almost 1. You can see our data sets are actually skewed. We can also use that to compute the corpuses of our data set in order to see the height of each of the services, the amount of money that was spent by the customer on each of the services. We can use this to see that, to see the amount of money that was spent in each of the services to see the peakness of the data set. That's the corpuses. So we can use that to see that for the corpuses. Now the corpuses here, you can see I'm making use of the E1071. You can see that coming up there. So the function I'm using for the corpuses is now from the moment values from the E1071 package. So now we can use this to compute the corpuses for the amount of money spent by the customers on each of those service. Okay, we can simply run that, and that gives us the corpuses for each of that particular services. Now, now we can see for that of the rental equipment, the corpuses is negative, and we can see for that of the normal code is the peakness of the distribution of the amount of money spent by the customer on long distance code is um, very high. That gives us a linked data set. Also, this is not a linked in nature because it's more than three. It's more than three. That's linked in nature. Why this gives us. So we can see that for each of the data sets we can see the main value. We can see how to compute the measure of central tendency and the measure of dispersion in our studio. Now let us see how we can do the same thing, how we can compute the measure of central tendency, how we can do the same thing using the XPSS. We can see how we can do that in our studio. Let us see how we can do that using the XPSS. Now, this is XPSS. This is my data set in XPSS. And this is the variable for the data set. This is the name of each of our variable in XPSS. You can see our variable of interest, that's the long one, the long distance call, as you can see that long distance call for last month, the toll month, the toll free call for last month, the quick month, the equipment for last month, and the card month, calling card for last month, and the wire month, wireless service for last month. Now, these are the table So we are going to see how we can also compute the measure of central tendency and measure of dispersion using SPSS.